Good day, engineers. I am Engineer Rodolfo, and today we will be discussing about the lateral earth pressure for sloping backfill using the Rankine equations. So this is for the course Foundation Engineering. So let's start. So from our previous topic, we have discussed about the Rankine passive and active earth pressure for a horizontal backfill. So doon meron tayong active earth pressure coefficient which is equal to 1 minus sine of V over 1 plus sine of P. Then, for the passive earth pressure coefficient, we have 1 plus sine of V over 1 minus sine of V, which is also equivalent to 1 over Ka. So, dito sa Rankine active and passive earth pressure for sloping backfill, same pa rin yung concept ni active tsaka ni passive. So, for active, if ito yung retaining wall natin in its initial position, if that yields outward, o ibig sabihin yung soil is itutulak niya yung retaining wall papalayo and the rotation is counterclockwise. So, ibig sabihin, that is an active earth pressure. Then, kapag yan, or yung retaining wall naman natin has an initial position na to, then it yields inward. So, ibig sabihin nun, that is a passive earth pressure. And ang rotation is clockwise. So, yun pa rin yung concept for active and passive earth pressures. So, ang pinagkaiba lang dito is such that gagamitin natin yung Rankine equation for an inclined backfill. Ibig sabihin, kapag nandito tayo sa taas ng retaining wall, yung lupa mo is nakaka-inclined pa ng pagganito. Then, kapag sinukat natin yan, coming from its horizontal plane, sinukat natin, it will have an angle equivalent to a value beta. So, that is the inclination upward or meron siyang slope M na inclined na pagganito or inclined lagi siya upward from the horizontal. So, kung kukuha tayo ng element coming from an inclined backfill, which is ito, at a depth Z, palalakihin natin yan. So, as you can see, dito sa figure na to, meron kang makikita na plane AB and plane DC, which is inclined at an angle beta. So, ibig sabihin, ang normal force nitong plane na to, which is ito, is inclined at an angle beta from the vertical axis. Then, yung shear stress for this plane will have or will be parallel to the plane AB. So, ibig sabihin, yung equations for a sloping backfill can be derived using the concept of Mohr circle. So, yung equation na gagamitin natin dito is makukuha natin using the concepts of Mohr circle. Ngayon, punta tayo sa pressure distribution nitong inclined backfill. Originally, kapag horizontal yung backfill natin, ang pressure distribution natin is ganito. Meron kang right triangle. Pero, for a sloping backfill, as you can see in this figure, yung plane sa ibaba is naka-inclined at an angle beta. Ibig sabihin, parallel siya dun sa inclination ng backfill mo. Then, ma-observe mo din dito sa figure na to na yung force or yung resulting force or thrust dun sa wall is also inclined at an angle beta. But still, yung point of application or kung saan tatama yung force or yung location ng force dun sa retaining wall is still h over 3 from the bottom of the retaining wall. So, ibig sabihin, we can have an equation for the pressure equivalent to gamma HKA. Yan ngayon yung lateral earth pressure, which corresponds dun sa nasa bottom, which is ito. This is the gamma HK. Itong part na to. Then, yung height nung or yung retaining wall has a height h. Ibig sabihin, ang height ng triangle na to will be h. So, we can have the resulting equation for the total thrust on the wall equivalent to an area of the triangle, which is 1/2 of P, kasi ito yung P niya, this is P, kasi ito pwede nating serve as to as F. So kung ito yung P niya, that is equal to 1/2 P times H. So ibig sabihin, if we further simplify this one, that will be 1/2, that is gamma H K times H. So, ibig sabihin, that is 1/2 gamma H squared K. So, yun yung concept for determining the active and passive thrust of the wall for a sloping backfill. So, now we will proceed to pressure coefficients or the equations for the pressure coefficients. So for the equations for the pressure coefficients, we have the active earth pressure coefficient equivalent to K sub A is equal to cosine beta times cosine of beta minus square root of cosine squared beta minus cosine squared of phi divided by cosine of beta plus cosine squared of beta minus cosine squared of phi. So, kailangan nyo ng mnemonics para makabisado yung equation for the active earth pressure coefficient para masolve yung lateral earth force sa sloping backfills. So, yung beta dito is the inclination of the backfill. Then yung phi is the angle of internal friction or the angle of shearing resistance. So, kung pupunta tayo on the side of the passive earth pressure, that will be K sub P is equal to cosine of beta times cosine of beta plus square root of cosine squared of beta minus cosine squared of phi divided by cosine of beta minus square root of cosine squared of beta minus cosine squared of phi. So as you can see, Yung equations nila is may resemblance dun sa original equation for a horizontal backfill, which is for active earth pressure coefficient, that is 1 minus sine of V over 1 plus sine of V. So, mapapansin nyo, dito sa sloping backfill, yung minus niya kapag active nasa taas, yung plus niya nasa baba. Same as for passive earth pressure coefficient for sloping backfill, yung positive niya nasa taas, yung negative niya nasa baba. Which is kapag horizontal backfill yan, that is 1 plus sine of V over 1 minus sine of V. So, if we're going to solve that one, or we're going to solve a horizontal backfill using the equations for a sloping backfill, we can produce the original equation. So, ipapakita natin yon dito sa next slide. So, if we're going to use the formulas nung sloping backfill para sa horizontal backfill, we will set the beta or the inclination of the backfill equivalent to 0. Substituting beta is equal to 0. So, kung yung active gagamitin natin, so we will have cosine of 0 times cosine of 0 minus square root ng cosine squared of 0 minus cosine squared of phi times or divided by cosine of 0 plus square root ng cosine squared 0 minus cosine squared of phi. So, if we will solve cosine 0, that will be equivalent to 1. So, the resulting equation, if we substitute 1, so that will be 1 minus square root ng 1 minus cosine squared of phi divided by 1 plus 1 minus cosine squared of phi. As you can see, we have a trigonometric identity which is 1 minus cosine squared of phi. From trigonometry, we have 1 minus cosine squared of phi equal to sine squared of phi. So, we can substitute sine squared of phi dito sa equations na to. Or dito sa equation na to. So, ibig sabihin, we can have an equation of k sub a is equal to 1 minus sine squared of square root of sine squared of phi over 1 plus square root ng sine squared of phi. So, if we will get square root of sine squared of phi, that will be equivalent to sine of phi. So, the resulting equation, if we will get the square root of sine squared of phi, that will be k sub a is equal to 1 minus sine of phi over 1 plus sine of phi. This equation is the equation for the horizontal backfill. Ibig sabihin, mapapalabas natin yung equation ng horizontal backfill if we will use the equation for sloping backfill. So, itong concept na to is pwede nating tandaan para matandaan din natin yung format ng equation for a sloping backfill. So now, we can proceed to sample problem number 1. For sample problem number 1, a wall 5 meter high retains sand having a unit weight of 18.4 kN per cubic meter and an angle of internal friction of 27 degrees. If the surface of the backfill slopes upward at 10 degrees to the horizontal, find the active and passive thrust per unit length of the wall. So we will solve this sample problem in GRESA format, meaning that is a given, required, equation, solution, then answer. So for the givens, we have a wall height equivalent to 5 meters, which is the h, a unit weight of soil, gamma, which is equal to 18.4 kilonewton per cubic meter, and the angle of internal friction, or the angle of shearing resistance, equal to phi, which is 27 degrees, and the angle of inclination of the backfill, beta, is equal to 10 degrees, which is upward from the horizontal. So, drawing pa natin yan. So, ito yung retaining wall. Then, ito yung backfill niya, which is sloping. Sabi dun, this is the beta, which is, that is the 10 degrees. Then, ito yung height ng retaining wall, which is 5 meters. So, that is, or that are the given for this problem. So, for our required, we have the active and the passive earth force or the earth thrust for the wall. So for the equations we are going to use, so for the active earth force or earth thrust on the wall, we should use the active earth coefficient equation for sloping backfill, which is K sub A is equal to cosine of beta times cosine of beta minus square root ng cosine squared of beta minus cosine squared of phi divided by cosine of beta plus square root ng cosine squared of beta minus cosine squared of phi. Then we will get the passive earth pressure or the active earth pressure, which is equivalent to gamma times H times the active earth pressure coefficient K sub A. Then we can get the active earth force coming from the diagram, which is just the area of the triangle, which is 1/2 the pressure or the active earth pressure times H, or just simply 1/2 gamma H squared Ka. Then for the passive earth force or the passive earth pressure, we could have the passive earth pressure coefficient, which is cosine of beta times cosine of beta plus square root ng cosine squared beta minus cosine squared of phi divided by cosine of beta minus square root ng cosine squared beta minus cosine squared of phi. Then, the passive earth pressure, which is equivalent to gamma H times the passive earth pressure coefficient, which is K sub P, resulting to the passive earth force, which is 1/2 times the passive pressure times H, or simply 1/2 gamma H squared K sub P. For our solution, we will first get the active earth coefficient using the equation of Rankine for sloping backfill. So that is K sub A is equal to cosine of beta times cosine of beta minus square root ng cosine squared of beta minus cosine squared of phi divided by cosine of beta plus square root ng cosine squared of beta minus cosine squared of phi. So we will substitute the value beta, which is equal to 10, and the angle of internal friction phi equal to 27 degrees. So we will have cosine of 10 degrees times cosine of 10 degrees minus square root ng cosine squared ng 10 degrees minus cosine squared of 27 degrees divided by cosine 10 degrees plus square root ng cosine squared of 10 degrees minus cosine squared of 27 degrees. Then, calculating the value of K sub A or the active earth coefficient, we will have a value of 0.3965, So, tama lang ito kasi we are in the active earth pressure or the active earth force. So, dapat ang value ng earth pressure coefficient niya will be less than 1. So, if we will solve the active earth pressure, we will have P sub A is equal to gamma H times Ka. So substituting gamma, which is 18.4, then 5, we will have P sub A is equal to 18.4 kilonewton per cubic meter times 5 meters times 0.3965. As you can see, magka-cancel out dito si meter cube, magiging squared na lang to, so yung meter dito makakancel. So, ibig sabihin, ang resulting value natin will have a unit of kilopascal. So, that is P sub A is equal to 18,239 over 500 kilopascal. So, yun yung active earth pressure natin. Hindi pa siya yung sagot kasi ang hinahanap natin is yung active earth force or yung active earth thrust dun sa wall. So, para ma-solve yun, kukunin natin siya dun sa area ng triangle. E di ba, ang area ng triangle is ito. For ito is, kung ito yung H, meron siyang P na nandito. So, that is 1 half P sub A times H. So, substituting the values, so we have 1 half times 18,239 over 500 kilopascal times 5 meters. So, yung kilopascal, equivalent siya, diba, sa kilonewton per meter squared. So, ibig sabihin, itong nasa ilalim is magka-cancel, magiging meter na lang, then ito is makaka-cancel. So, ibig sabihin, ang resulting unit natin is in kilonewton per meter, which is calculating the value using your calculators, we have 80,239 over 200 kilonewton per meter. Naka-per meter yung unit natin ng force kasi we are calculating the force per meter strip nung retaining wall. Kasi masyadong mahaba yung retaining wall, ginawa nating analysis is per meter strip lang. Hindi natin binuo yung buong length ng retaining wall. Tsaka wala siya dun sa given natin. So, we will always analyze the retaining wall per meter strip unless otherwise stated na hinahanap niya yung total force given yung length ng retaining wall. So, if we were going to solve naman for the passive earth coefficient using the Rankine backfills equation or the Rankine sloping backfill equation, we will have K sub P is equal to cosine beta times cosine beta plus square root of cosine squared beta minus cosine squared of Phi divided by cosine of beta minus square root of cosine squared beta minus cosine squared of Phi. Substituting beta of 10 and Phi of 27 degrees, so that is K sub P is equal to cosine 10 degrees times cosine 10 degrees plus square root ng cosine squared 10 degrees minus cosine squared 27 degrees divided by cosine of 10 degrees minus square root of cosine squared of 10 degrees minus cosine squared of 27 degrees. Calculating this one, we will get a passive earth coefficient of 2.4462. So, for passive earth coefficient that is always greater than 1.0. So, after solving the passive earth coefficient, we will solve for the passive earth pressure coming from the equation P sub P is equal to gamma H K sub P. So, puro direct substitution, basta kabisado natin yung formula and yung procedures. So, that is P sub P is equal to 18.4 kilonewton per cubic meter times 5 meters times 2.4462. Calculating that one, that will result into a value of P sub P is equal to 225.0504 kilopascal. So, na kilopascal yung unit kasi this will cancel out. This will be 2. Then, this will be cancelled. So, calculating for the required, which is the passive earth force or the passive earth thrust on the wall, that is using the area of the triangle, which is 1/2 times P sub P times H, or some textbooks use it as 1/2 gamma H squared Ka. So that will be F sub P is equal to 1/2. Substitute natin si P sub P, which is ito, dito. So that is 225.0504 kilopascal times the height of the retaining wall, which is 5 meters. So calculating F sub P, it will result into 562.626 kilonewton per meter. So, yung units nung answer natin is still in kilonewton per meter, meaning that is a per meter strip analysis. So, for the answer, for the active earth force, we will have F sub A is equal to 182 or 18,239 over 200 kilonewton per meter, and for the passive earth force F sub P, that will be 526.626 kilonewton per meter. So let's proceed for sample problem number 2. A vertical retaining wall supports a backfill having a height of 6.2 meters. The backfill has a unit weight of 17.5 kilonewton per cubic meter, an angle of shearing resistance of 30 degrees, and it is sloping at a ratio of 2:13. So we will need to determine the following. First, the active earth force. Then next, the horizontal and vertical component of the active force. Then third will be the passive earth force. So we will solve this again in GRESA format. So we will have the given, which is the wall height equivalent to 6.2 meters. The unit weight of the soil, which is gamma, is equal to 17.5 kilonewton per cubic meter. An angle of internal friction, or the angle of shearing resistance, phi of 30 degrees, and the ratio of the slope, which is 2:13. So as you can see, wala sa given, automatically yung beta. So we need to solve for the value beta. So for the required, so kailangan natin hanapin yung active earth force or yung active earth thrust, yung horizontal and vertical component of the active force, and yung passive earth force. So for the equations, yun pa rin yung gagamitin natin. Yung active earth pressure coefficient equation for sloping backfill, yung pressure or the active pressure, which is gamma HKA, and yung active thrust on the wall, which is the area of the triangle, 1/2 P sub A times H. Then, para dun sa passive earth pressure, we will have K sub P is equal to cosine of beta times cosine of beta plus square root ng cosine squared beta minus cosine squared of phi divided by cosine of beta minus cosine squared of beta minus cosine squared of phi. And then, the passive earth pressure, which is equivalent to gamma HKP, and the passive earth thrust or the passive earth force, which is the area of the triangle, which is 1/2 P sub P times H. So for our solution, we need to solve first for beta. Pero ang given sa atin is a ratio. So yung ratio na yun, sabi, yung first number dun sa ratio is the rise and the second number is the run. So meaning, the ratio correspond to rise is to run. So ibig sabihin ng rise, that is yung vertical component or yung vertical plane ng triangle, then yung horizontal plane ng triangle is yung run. So using trigonometry, we will have the tangent of beta. So itong angle na to will correspond to an angle beta. So kung titignan natin, if ang given natin is rise is to run, ibig sabihin from trigonometry, so from SOHCAHTOA, that is tangent is equal to opposite over the adjacent. Whereas, ang opposite ng beta natin is yung rise, then yung adjacent niya is run. Therefore, creating an equation, tangent of beta is equal to rise divided by the run. Whereas dun sa given natin, yung rise natin is equal to 2 and yung run natin is equal to 13. So that will be tangent of beta is equal to 2 over 13. Therefore, we have beta is now equal to tangent raised to negative 1 of 2 over 13. So solving this one using our calculators, we will have a beta equivalent to 8.7462 degrees. So we will now have our beta, which is 8.7462 degrees upward from the horizontal. So we can now solve for the active earth coefficient using the equation for sloping backfill. So that is still Ka is equal to cosine of beta times cosine of beta minus square root ng cosine squared beta minus cosine squared of phi divided by cosine of beta plus cosine squared of beta minus cosine squared of phi. Substituting yung value ng beta na nakuha natin from the ratio rise is to run, and yung given natin na 30 degrees, we will have cosine of 8.7462 degrees times cosine of 8.7462 degrees minus square root ng cosine squared of 8.7462 degrees minus cosine squared of 30 degrees divided by cosine of 8.7462 degrees plus square root of cosine squared 8.7462 degrees minus cosine squared of 30 degrees. Calculating that one, we will have a value of the active earth coefficient equivalent to 0.3455. After getting the active earth coefficient, we should now get the active earth force. So, solving for the active earth pressure, we can have, using the equation, gamma HKA, substituting gamma, which is 17.5, and the height of the retaining wall, which is 6.2 meters, we will have 17.5 kilonewton per cubic meter times 6.2 meters times 0.3455. Solving this one, we will get an earth pressure equivalent to 37.4868 kilopascal. So as you can see, puro direct substitution yung ginagawa natin dun sa problems. Then, we can now solve for the active earth force just by using the area of the triangle, which is FA is equal to 1 half PA or P sub A times H. Substituting P sub A, which is 37.4868, and the height of the retaining wall, which is 6.2 meters. So we will have 1 half times 37.4868 kilopascal times 6.2 meters. So, same units, kilonewton or kilopascal is equivalent to kilonewton per meter squared. So, ibig sabihin, ito magka-cancel. We will have a unit or a final answer having a unit of kilonewton per meter. So, that is 116.2091 kilonewton per meter. So, meaning we have analyzed the retaining wall per meter strip. So, for the horizontal and vertical component of the active force, we need this figure to determine kung paano natin isolve yung horizontal and vertical component of the active force. So, based from the concept, sabi dun, si active force is inclined at an angle beta from the horizontal. So, sabi sa concept, that is parallel dun sa inclination nung mismong backfill. So, ibig sabihin, ito yung beta niya. So, by using the principles of trigonometry, so we will solve for the horizontal component of the force. So, ibig sabihin, we will use cosine beta. So, from SOHCAHTOA, that is, cosine is equal to adjacent over the hypotenuse. The adjacent side coming from this figure is itong FAH. So that means we will have a cosine of beta is equal to FAH over FA. As you can see, meron tayong given na beta or nakuha natin yung beta at meron na tayong F sub A, which is the active thrust or the active force on the wall. So substituting those values, we will have cosine of 8.7462 degrees is equivalent to F sub AH divided by 116.2091 kilonewton per meter. Then cross-multiplying, we will have F sub AH is equal to 116.2091 kilonewton per meter multiplied by cosine of 8.7462 degrees. So calculating, we will have a horizontal component of the active force equivalent to 114.8578 kilonewton per meter. So still, that is a per meter strip analysis of the retaining wall. So next, we will get the vertical component of the active earth force. So from trigonometry ulit, we will get the vertical component of the force. So pwede kasi nating ilipat si vertical component dito. So pwede nating sabihin na coming from SOHCAHTOA, that is sine is equal to opposite over the hypotenuse. So that is a sine of beta equivalent to F sub AB, or the vertical component of the active force, divided by the active force. Substituting beta, which is 8.7462, and the active force na nakuha natin kanina, which is 116.2091, we will have sine of 18.7462 degrees equivalent to FAV divided by 116.2091 kilonewton per meter. So, cross-multiplying, ito papupuntahin natin dito. Then, may iwan dun sa FAB. We will have FAB is equal to 116.2091 times sine 8.7462 degrees. We will now have a value of FAB, or the vertical component of the active force, equivalent to 17.6705 kilonewton per meter. So, ang last requirement natin para dun sa problem natin is yung passive earth force. So, gagamitin ulit natin yung equation for the passive earth coefficient for sloping backfill, equivalent to K sub P is equal to cosine of beta times cosine of beta plus square root ng cosine squared of beta minus cosine squared of phi divided by cosine of beta minus square root ng cosine squared ng beta minus cosine squared of phi. Substituting yung mga nakuha nating values kanina tsaka yung given. So, substitute natin si beta at tsaka yung angle of internal friction na 30 degrees. So, meron kang cosine of 8.7462 degrees times cosine of 8.7462 degrees plus square root ng cosine squared of 8.7462 degrees minus cosine squared of 30 degrees divided by cosine 8.7462 degrees minus square root ng cosine squared 8.7462 degrees minus cosine squared of 30 degrees. Calculating that one, we will have a passive earth coefficient equivalent to 2.8272. After nating makuha yung passive earth coefficient, didiretso tayo sa pagkuha ng passive earth pressure. So, gagamitin ulit natin si gamma H times K sub P. Substituting the values, so we will have 17.5 kilonewton per cubic meter times 6.2 meters times 2.8272. So, itong value na to magka-cancel, magiging meter squared. Ito magiging meter. So, ang resulting equation or ang resulting value natin will have a unit of kilopascal. So, that will be P sub P, or the passive earth pressure, equivalent to 306.7512 kilopascal. Then, solving for the required passive earth force, so gagamitin lang ulit natin yung area of the triangle. So, we may now have F sub P is equal to 1/2 P sub P times H. So, pwede rin natin gamitin yung F sub P is equal to 1/2 gamma H squared KP. So, that is F sub P is equal to 1/2 times 306.7512 kilopascal times 6.2 meters. So, kilopascal still corresponds to kilonewton per meter squared. So, canceling this one. So, we will have a unit of kilonewton per meter. So, the resulting value will be F sub P is equal to 950.9287 kilonewton per meter. So, we have analyzed it per meter strip. So, para dun sa mga answers natin, sa mga required, so for letter A, that is active earth force. So F sub A is equal to 116.2091 kilonewton per meter. For B, that is the horizontal active earth force, which is equal to F sub AH is equal to 114.8578 kilonewton per meter. And for the vertical active earth force or the vertical component, that is F sub AV is equal to 17.6705 kilonewton per meter. And for the last required, that is the passive earth force, which is F sub P is equal to 950.9287 kilonewton per meter. So, sa topic na to, kailangan lang natin tandaan is yung equations for the active and passive earth coefficients as well as yung concepts ng active and passive earth. So, sa active and passive earth, kapag active, yielding outward, rotation ng retaining wall is counterclockwise. Then, for the passive earth force, that is kapag yung retaining wall is yielding inward and it is rotating clockwise. So that will be for this topic for the lateral earth pressure for sloping backfill using Rankine's theory. So thank you for watching.